Okay, I did actually this problem. I just cut it because the video turned out to be more than 15 minutes long and they kicked me out. So there were two problems on it, so I'm just going to switch it to one problem and just do this problem. Now after I started doing it, actually I changed my mind how I'm going to do it. I had it done before using a different method, but I'm going to change it. I don't like what I did there. So here's what I know. A three-phase source. It doesn't really say Y. It's a Y. I just forgot to write that. A balanced Y three-phase source. So my source is actually, it's a Y source to Y load. And notice what we know. We know the magnitude of VAB, which is 208. So VAN is going to be what? Is going to be, you take VAB, which is 208, and you divide it by the square root of 3. And if you do that, you end up with 120. And if they don't give you a phase, a lot of times they want you to make the assumption that's an angle 0 here for this one. So this is just the magnitude of that line voltage. So we're going to make that angle 0. The next one is minus 120, and the next one is negative 240. It's going to two loads. Here's load number 1, which absorbs what? 60 kVA. I should have made it bigger. Power factor 0.8, and it's lagging. And there's load number 2. Load number 2 is what? 30 kVA at 0.7, lagging. And the problem didn't say that's really the total load for the whole thing. So per phase, per each phase, I need to take that number and divide it by 3, because I'm looking at per phase. So per phase here, this really should be 20 here now. And that should be a 10, because that's for all 3 of them. 30, you divide it by 3, that's 10. 60, you divide it by 3, that's 20. So per phase, each one of these load, this is number 1, load 1, and this is load number 2. So what do we know about that load? Here's what we know. They're giving us the complex power. Let's go to complex power. We know this is 20,000. We can figure out what this angle, that's the inverse cosine of 0.8. What's my inverse cosine of 0.8? Third cosine of 0.8, that's 37 degrees. This is number 1. So I can find this value and I can find that value for it because I need the complex power, Q. This portion is the real power, and that's Q, that's the imaginary power. That's the average power. That's the VAR, VAR. How do you get this number? We can use the cosine. Cosine 37 degrees equals x over 20k. So what's x equal to? Take the cosine of 37, which is 0.8, times 20, that's 16 kilowatts. And the imaginary value right here, we'll call it y, is going to be what? Sine of 37 times the 20. So what is the sine of 37 degrees times the 20? That's roughly 12 kVAR. So when you look at S1 complex power, S1 is going to be 16 kilowatts. Well, let's not put the kilowatts in. Let's put just 16K. Well, let's put the K at the end. Plus 12J kVA, complex power. Now let's look at source number 2, or load number 2. Sorry, load number 2. That's at 10K. Let's find this angle. Inverse cosine of 0.7. Power factor. Power factor equals cosine theta V minus theta I. And it's 45 degree, roughly. So x is going to be what for this one? This is x and this is y again. X is going to be the cosine of 45, which is 0.7 times the 10K, that's 7 kilowatts. And y the sine of 45 should be the same. It's the same as the cosine of 45. You multiply it by 10, that's a 7. Up, kVA, var. So S2 here is going to be 7 plus 7J, that's the imaginary one, kVA. So if we add these two complex powers, we have the complex power of the whole load. So I'm trying to find out what is the complex power of the load. So here we go. S total here is equal to S1 plus S2. So that's 16 plus 7 is what? 23. Plus 7 and 12 is 19J kVA. Remember what complex power is equal to. So what the question is saying, if we replace this by one load, what is the value of that? So this is 120 angle 0. And this is the total load here, the one load, which is the 23 plus 19J kVA. One load. This current, this is A, that's capital A. This is I sub AA. Well, if you remember what complex power is, not K, complex power is what? V times I conjugate. Which means I conjugate equals S over V. Well, we know what S is. I just found it right there. 23 plus 19J, that's in thousands, over V, which is what? 120 angle 0. So here's my calculator. Let's try that. 23,000 plus 19,000 J. Where's my J here? Here we go. Divide that by 120 angle 0. And I got 248.6 angle what? 39.6. That's my current. Amps, and these were RMS values, by the way. Oh, wait a minute. This is the conjugate, right? So what is my I is going to be? It's going to be 248.6 angle negative 39.6 amps, and this is RMS. The question, what's the power factor? Power factor is equal to what? cosine theta v minus theta I. Well, my theta v is 0 minus my theta I is negative. That will make it a plus. So what's cosine? Is it 39? Yeah, 39.6 I got, unless I pushed the wrong button. So what is the cosine of 39.6? Came up with 0.77 roughly. And since this angle is positive, that's a lagging power factor. Because the second question was, what is the power factor for the entire load there, and what was the current I sub A to A? So we found both of these, and hopefully this is short enough so I can post it.